What if a computer program could help you beat a breast cancer diagnosis? What if it were so precise that you could use it for a treatment plan? These are the questions a group of scientists at LSU are asking themselves as they race to build an AI software so sophisticated it can do just that. Take a look. Breast cancer is the second leading cause of death for women in the U.S., and its ubiquity is becoming more prevalent among younger groups of women. The U.S. Preventative Task Force is suggesting women start breast cancer screening at 40 years old instead of 50, which was the original recommendation. Meanwhile, the American Cancer Society is recording an annual 0.5% increase in breast cancer incidences. While treatment is best handled before the cancer is detected, there is a movement among scientists to precisely pinpoint treatment plans after a diagnosis. And it's starting at LSU.
I'm associate professor in the Department of Biological Sciences at LSU and also associate director for data science and machine learning in the Center of Computation and Technology.
Dr. Michael Berlinski is focusing his research on treating breast cancer with AI technology.
Whenever a lot of people think of AI, and whenever I say a lot of people, I'm talking about myself, they think of, robots running around, picking out different drugs for a cancer patient.
No, it's basically a computer program. So I would say that 90% of my time is just coding or people in my group. So we just code all the time. So AI in sense of a computer program that is going to be trained on existing data, and then it's going to be able to make predictions. So that's basically software.
The software takes all of the available data on breast cancer, prostate cancer, and pancreatic cancer, plus information from the patient's DNA. From there, AI can pinpoint a drug plan unique to that particular patient.
So our idea is to use the genetic profile of a particular cancer to figure out what's the best therapy against that cancer. And even cancer of the same time, but from different patients, they may have slight variations in their genetic makeup, and AI is going to account for this and suggest the most efficient drugs.
The treatment is going to be very unique to that particular patient.
Yes, this is correct.
Can you give me an example?
Yes, so that's still a very long shot. So right now we are doing basic research. So we work on cancer cell lines in vitro, that's in the lab. However, each cell line that we work with was originally obtained from a cancer patient, right? So those are like real cancers that somebody had in the past, and they were immortalized, and now people use them in the lab. So the data that we would need is the genetics, the genetic makeup, gene expression profiles, and all those things as an input for AI. And then AI is going to select the most efficient drug against that particular, in our case, it's a cell line, but eventually it could be patient.
Here's an example of the cells Berlinski is talking about. These are cancer cells from a 70-year-old patient. The cells on the right are cancerous, over-reproducing in mass. This is the control group left untreated. On the left is a group of the same cancer cells treated with a drug treatment plan selected by AI. You can see the movement is slower, and the cancer is stalling.
We run this in control and drug treatment side by side, right? So in those videos that I sent you, in control, you will see that those cell lines proliferate like crazy because this is what cancer does, right? It's a very aggressive disease and it grows like really, really fast. Whereas those cell lines that were treated with drugs selected by AI didn't grow that much or even died. So that was the proof that AI was actually right, suggesting this molecule against this particular cancer.
Berlinski and his team of 10 aren't the only biologists using AI to treat this disease. Dr. Sungwon Yang is using AI to improve breast cancer detection so that preventative care is more precise. Their research uses an algorithm to diagnose breast cancer in all areas using one mammogram picture. The science is new, and it'll take years of testing before AI tech is used on human beings. But Berlinski says this could change the course of medical treatment in all fields.
It's a tool that can guide and help. So this is how AI should be used, I believe.